So just looking over the agenda, what we're going to cover today, as it is a broad topic when we're talking about material traceability and management with steel fabrication, we're first going to take a look at what Graitec Advanced Workshop is. So this is a relatively new product in the Graitec IP portfolio. It's not necessarily a new product. It's been in development for over 30 years, but it is relatively new in the North American market. We've been introducing it we've introduced it in the last 2-3 years. So we'll just first take a quick overview of what Graitec Advanced Workshop is, and then we'll take a look at how we can leverage metadata from Autodesk Advanced Steel and basically manage all actions post-design. So everything from purchasing material to driving fabrication orders in the shop to assigning operations per workstation, part routing, and also driving NC data from Advanced Workshop to the shop. Once again, everything from customer orders to fabrication orders to purchasing materials and stock management. Again, these are broad topics, so we're just going to be touching over these different facets briefly. Again, my name is Tommy Moussis. I'm a solution architect. I've been working with Graitec for approximately 10 years now, and I come from industry as well. So I've worked in multiple fabrication shops as not only a dealer, a detailer, but a quality control manager as well, and worked in design. There's many different ways of managing data within companies, businesses of this type. Okay, and there's a lot of moving parts to it, depending on the types of projects that are being managed. For example, government projects versus local county projects, and more, there's a lot to take into account with new ISO standards being deployed, and a lot more traceability required with key trace documents, CE documentation as well, going along with materials. So our solution, Advanced Workshop, really facilitates all those aspects as well as just general management. So these are the types of things that we're going to talk about today. And again, I come from industry, worked in both Canada, US, actually in the United Kingdom as well. So hopefully I'll be bringing some of those experiences for you all today as well. Okay, so we're to start now with a general overview of Advanced Workshop. So just so you all know where this sits in the BIM cycle, okay? So this is ultimately a manufacturing execution system. Oops, change slide there. So this is ultimately a manufacturing execution system, but it encompasses many more features than just features to drive data in your workshop. Just to give an idea, so the solution is mainly meant to cover the fabrication process, but you can also have a simulated time and cost calculation, so a 4D and 5D analysis of the project. This is due to the fact that we allocate cost per operation to all operations that need to be executed on raw material to be transformed to then be expedited on site. We also manage logistics, so everything from truck loading to contracting, and of course, all operations have time coefficients applied to them. So this will obviously give you forecasted dates and actual dates for delivery and so on. And we also have traceability on all documentation. So one of the, I think, not main pain points, but one of the big pain points of steel fabrication is keeping traceability on these documents on remnants or drop-offs on materials. So after material is being processed, of course, if a bar length exceeds X in feet or inches, you would like to keep that in stock and perhaps utilize it on another project. So it will help you with traceability on these documentation, so that at the end of your deliverable, you'll be able to submit all CE documentation and key trace documentation related to remnants in your stock and general documentation. So of course, all submittal type reports and drawings that are linked to projects can all be stored within Advanced Workshop as well. So this is where it sits in the BIM workflow, and of course, other Graitec IP and Autodesk IT are more aligned with conceptual design, detailed design, and analysis. So one of our main objectives is to be able to facilitate importing of this data, this metadata from these CAD solutions into Advanced Workshop to eliminate the mundane work of entering customer orders and proposals manually. So we do have import mechanisms to import BIM files so that it compiles all objects to an order and compiles cost to an order automatically. So here's just a chart showcasing all the different moving parts to a steel building project. So there's the customer inquiry, supply chain, production, logistics, quality, accounting, and steel delivery. And of course, within these categories, there's sub-tasks. Advanced Workshop is meant to manage all tasks displayed here. Okay, so everything from customer inquiry all the way to steel delivery. And I should mention it is a modular solution, so we can tailor the solution to fit specific workflows or to only utilize the solution for maybe one or two parts of the business, because we do appreciate that a business may already have a material resource planner or an ERP in place and maybe not have a manufacturing execution system. So again, the solution is modular, but these are all the tasks we can manage within the platform. So just to give a nice functionality coverage here, on this one slide, it really describes well everything that we cover from A to Z. So one thing to mention is that Advanced Workshop is not considered an enterprise resource planner just because we do not manage payroll and general ledgers. Most companies have an accounting solution in place, so the objective is to export data from our platform and create interfaces to import or export data from our platform into said accounting system. But it is an MES, manufacturing execution system with much, much more. So it is a multi-architecture solution. What this means is that within the platform, you can have multiple companies, multiple factories linking to each company profile, and multiple warehouses linking to each factory. So if you're a larger entity or have sister companies that would want to be on the same platform, this is possible with our solution. Of course, with units, we manage both metric and imperial. We have multiple language settings, multiple currency settings. And looking at the functionality coverage, with supply chain management, we cover sales, purchasing, business margins, credit control, job sites, invoicing. And with technical office, we can manage estimations, which is actually more so a quote tool where we can import an advanced steel model and compile the costs to the project automatically. I'll get into more details, more of the technical details and how we can do this later on. But of course, with that said, we have BIM integration, so we can import models from CAD solutions, we can import drawings. We also have other features to be able to scan DWG files, bill of materials on DWG files, and link them with SKUs in our system. And of course, consequently, this is managing the bill of material. Production and real-time monitoring. So once again, some of the Advanced Workshop at its core is a manufacturing execution system, and we have many other applications that go alongside with PDAs and tablets and or what we call touch boxes, which will have a PDA attached to the system. So by means of PDAs and tablets, we can then track material stock, manufacturing strategies as well. This is more of the schedule board within our system, but of course, we can manage employees by workstations afterwards with the tablet functionalities. We have a nesting module within our system, and we can even export data to other nesting solutions on the market, such as ProNest. We can track the order status, of course, and the order status is by operation, so we have traceability on all operations that need to get executed on each and every assembly or part component. We can download data directly to the machine and have run optimization, okay, to reduce material waste and so on. And of course, for stock management, we have two levels of stock management. We can also manage stock by geolocation. Again, we have route optimization for the shipping department, right? Once again, we can manage stock location by geolocation and truck loading and so on. So there's a lot to this solution, but again, it's modular. It depends really on what you need and what solutions you already have in place. So the technology itself, okay, so we support, of course, Autodesk and Graitec solutions with our import mechanism, written in .NET. We're using SQL as our database. And for integrations with other accounting solutions or ERPs, we've done integrations in passing with Sage, SAP, Microsoft Dynamics, Oracle, and many, many more, okay? This is just a list of a few. Now, when we're talking about the data structure in Advanced Workshop, okay, this is a macro overview of what needs to be done in our solution or the different tasks, once again, at a macro level. So, of course, you're to create your customer profiles, and then once you've created your customer profile and the job has been awarded, prior to the job being awarded, you're to create your job site, right? Because you can have multiple bids on the same job site for different parts of the project when even referencing just the seal alone. So you're to create your job site, and then once the project is awarded, then afterwards you're going to, of course, link any documentation in Advanced Workshop, but then you're to go through the design process in your CAD department. Now, this could be subcontracted. Not every fabricator have detailers in-house, so that could be subcontracted as well. But once the design is complete, then you'll import the metadata from that CAD solution and then manage the structural elements. So structural elements meaning bars, plates, assemblies, and all operations. And from there, you're to create your fabrication order. Prior to that, there's a lot of decisions that need to be made or investigated, such as do you have material in stock to execute these tasks, and are they optimized in terms of routing for the correct workstations based off of your current reality. If your shop has hit critical mass, you're obviously going to need to allocate some work on another day, etc. So just managing your shop capacities, and then once you've executed your fabrication orders, you're going to then export the entity data for the appropriate machine. So some of the subtasks that we're to take a look at when talking about the elements, okay, or the structural elements, we need to once again take a look at what we have in stock. If we do have stock, then allocate it to said project, and if the stock levels are low for whatever material, then you need to go through the purchasing process, the procurement process, and then manage those logistics in themselves. To facilitate that, of course, we have a nesting module that will be linked to the fabrication order. And then once again, once we drive the DSTV data or the NC data to the shop, it'll then be tracked by our touch boxes or tablets. And then from there, once it's expedited, you can create delivery notes, loading lists, and even invoice with our platform. So this gives you an idea of why this is considered more than just a manufacturing execution system. Really, we're covering, it's a vertical solution for steel fabrication. That's really what it is. But it being modular, there's many different tasks that we can manage depending on what you currently have in-house. Okay, so we're to focus more on the manufacturing execution system side of things for today's session, and how this solution can help you take full control of your production, evaluate time, and calculate the workload by operation and by workstation. We're to take a quick look at stock management with the nesting module, and then we'll take a look at some post-production analysis, but more so we're to take a look at the theoretical values applied, just because for time we might not be able to get all the way to post-production analysis. But we will take a look at production planning and the link with Advanced Steel, of course. Another point to mention here is that the goal is to have a single source of truth with this platform. So this solution isn't necessarily just used by a project manager or someone in procurement. This changes the workflow of the business, and all these the different actions can be controlled through this one platform and trigger or manage the critical path for each department within your business. So it's really removing the need for Excel spreadsheets, Google Sheets, and things of this type, and having everyone consolidated within this one platform for traceability. Now, I'm just going to go ahead and share my screen, and we'll just jump right into the platform. Okay, I want to share the entire screen. Okay, so I believe everyone can see my screen now.
Yep.
Okay, thanks, Misty. So first, what we're going to do is actually take a look at advanced fields. So this is a model I'll be using today, and it's a smaller model, but it's going to be easier to view all the metadata in this way. When we're creating a custom order, I will not import the entirety of the model. We're going to focus on a couple of different assemblies just so it's easy to see how the numbers compile. Okay. One thing I need to do is actually relaunch because I still had it open in French. Apologies for that. You have to forgive me. I'm based out of Montreal, so often enough I have to open up the application in French. Okay. So just to give a quick explanation of that window that you just looked at, of course, there's you can have many different versions of a database or build, and for quality control purposes, if you want to test a new build prior to deploying it, you can use tools like this to just run through your different workflow and settings prior to installing a new release. That's what that UI was for. Anyways. Okay, so this is Advanced Workshop. Okay, so I'll just start by just explaining what we're looking at here and just a layout of the UI. So here towards the top, we have different ribbons. The ribbons are, it's not like a CAD solution where you have dedicated tools for specific tasks. They're going to be generic tools to execute base functions within the different tables. So for example, here we have an icon to validate, to close a window, to search for information within a table. Here we have the action to create a new entry, okay, modify an existing entry, duplicate it, and then here we have an icon to print any sort of report. For the most part, I would say 90% of the time, you're just going to stay on to this ribbon, but then if you wanted to back up a database or edit directly in SQL, you can manage it here. And then you can import and export data from this table here under display. But once again, the most part, you would just stay here in this ribbon. Now here towards the middle of the screen, you'll notice we have dashboards. Now, dashboard went into, this is just to highlight that you can have multiple dashboards, okay? And when logging into Advanced Workshop, you may have noticed there was a user profile when logging in. I was just logging in as an administrator to have access to all functionality, but you can set restrictions per department so that users can only view certain parts of the software and execute certain tasks. This is very important, especially if you're using Advanced Workshop for any HR-related tasks and things of that type. But here you can have multiple dashboards configured per user profile. And if you're more of a C-level or manager within the business, you can have multiple dashboards to view the KPIs per department. Now, it's not necessarily just for KPIs, but you can actually search and create widgets to filter specific information as well. Then here towards the left-hand side, you'll have the different menus. So as I have many menus displayed right now, but this is just to be able to highlight all features within the field package. Okay, so this is basically all the most common menus that you would utilize. it's just important to keep in mind that per department, you would probably only need 6 to maybe 7 of the menus to execute all tasks. You wouldn't need to manage everything you see here, okay? And then towards the bottom, here we have all the different menus available. There's a lot that can be managed within the platform and bespoke workflows that can be created as well. Just to give an idea, there's over 700 different menus available in the system. And in case you need something very specific, we can always leverage a table that exists, that has been developed for another application at some point in time, okay? But there's a lot of different menus and ways to manage information, but there's a specific workflow that's tailored for steel fabrication that is showcased here. Okay, now what we're going to do is just create a customer order. To do that, it's quite simple and easy to do. I'm going to open up the customer orders menu here, and whenever opening up any sort of menus, you'll notice there could be additional tabs that appear on the left-hand side. For example, here we have the research tab and the legend. So there's going to be color codes here to each customer order that you created, and it's just basically to call out the status with a color. So here we can see what's not balanced, what is in price, what has been balanced, partially balanced, in fabrication, partially checked out, what's on hold, etc. And everything here is customizable as well in terms of color and even naming convention for status. And then, of course, here you have many different ways of searching for information. Searching customer order based off of year, project type, job site, branch code if you're managing multiple branches of your business within the platform, market segment code, etc. Now, let's just go ahead and create a new customer order. I'm going to skip over a few different steps because, as you can see, there's a lot of information that can be applied to the order. There's a lot of fields. In order to create a customer order, all you really need are 2 fields just to save the entry. So here I'm just going to call this applied webinar. And then here under commercial customer, I'm going to select my commercial customer. So this could be a general contractor. If you're a steel fabricator that deals with more county-based projects and it's more of a business-to-consumer situation, maybe you're a company that specializes in miscellaneous steel railing systems and they're more private projects, both are one and the same, okay? So your customers can be general contractors or basic customers. Now here you can link a specific job site file if one was created. If not, it'll just default to a default job site file, which is configurable for customers, or if there's a specific job site that you're dealing with where you know that there could be extras and change orders applied, you would need to create your job site prior. But just by validating now with both those cells, I can then save my customer order. When applying the commercial customer, here under follow-up, we see that all the market segment codes, location codes, everything has been applied automatically here, or populated automatically. So this is based off of the customer profile. Okay, typically you'll assign a salesperson to that customer profile as well, and then apply the typical shipping codes if you're delivering by truck, and so on. And all of this can be modified, of course, if you're deviating away from the typical setup that you have with said customer. With that said, everything here will be compiled automatically, as well as the job site and address. Of course, when you're dealing with a general contractor, you might be invoicing to their address, but the location or when you're delivering the material can be another address. So this can always be changed afterwards here. Now, here under items, there's many ways that you can populate a customer order. If you wanted to, you could just apply SKUs directly from your system. These would be raw material item codes. So, for example, if you typically purchase a W shape from X vendor and you just wanted to create a customer order because you're a field service vendor and you're just distributing raw material, you can use it for that as well. So here, if I go and search in the item, so you can push F4 or just click on list, which I did there. Here now I'll bring up the item code menu. Item codes are SKUs in Advanced Workshop, so it's just a slightly different verbiage, but they're called item codes because there's much more data that can be managed than just a typical SKU in an MRP system. There's a lot of technical data pertaining to not only the material, but the actual NC data to your profile. So in any case, here I'll just search for an AICW shape. And just like that, by searching for that item and applying it to the system, here I can actually change the quantity, and then afterwards I can change the price, okay? So whenever you're dealing with an item, just note that there could be a purchase price, sales price, but any sort of pricing can be modified after the fact, okay? Now that's one way to populate your customer order is just by using SKUs from our system. And here, if you wanted to create a detailed part, you can actually do it within the platform as well. So if I wanted to add a steel part manually and avoid, if it's a smaller project, for example, and it's just a replacement part, a plate or a bar element for an existing project, you can add a steel part manually here. So I'll just give an example of adding a W shape, a bar element, but apply additional features to it, such as copes, cuts, holes, whatever the case is. So in terms of UI, I'm first starting off by adding a bar element. So here I would select my profile type, okay? So here I'm going to add the add profile, and then here I'll select my shape. So here, if you know that you're going to apply just one single miter in the plan view or elevation, you can of course select a specific shape. But we now have introduced this year a CAD editor, which will facilitate adding more complex cuts, copes, irregular shaped holes, etc. onto the object. So here for this example, I'm just going to select template 0, which is just a bar cut to length. Here I'm going to specify the assembly name, the attached part reference, the role of the item, and here I'm going to select the item code. So here, just by typing AIC, once again, W, here you'll see the list shortened, and I'm going to select a W12 by 26 for this example. I can then specify the coding, if it's going to be galvanized or if it's just going to be a raw process and then expedited. And then here I can specify my quantity and the length. So here I'm just going to just that is 5 foot in length for a quantity of 5. So from here we can validate. And now we'll see that we've actually populated the customer order. Here it's taking into account the quantity, and of course here we have now a difference in price because of course it's subcontracting from the raw material SKU. So the SKU could have been 20 feet, 30 feet, whatever you typically buy in terms of length from your vendor. So it's deducted from that length and then added cost coefficient for the shortening operation, because of course I only utilize 5 feet of that perhaps 20 foot length SKU. Now here, if I wanted to edit the steel element, I could just right click on the item in the customer order to launch the CAD editor. So from here we see the bar. We have a viewer here at the bottom where you can rotate, view the dimensions of course as well. And here, if you wanted to just turn off the dimensions, you could turn them off. You could change display type. So there's some nifty tools here that you can use to change the graphical settings. And then here, you can model in holes, shortenings. Again, apologies for the mix of French and English. So here, if I want to add, by the way, everything's available in just English. This is just me being in Montreal, Quebec. So what I'll do is just apply a shortening feature to give a quick example. And when applying a shortening feature, it's very similar to Advanced Steel or the Graitec Power Pack in the sense that it will present you a dialog where you can modify the values parametrically. So here, if I wanted to just adjust it by 2 inches, and then here change the rotation of the cut by 15 degrees and so on. Here I can put negative values as well, of course, to change the orientation, and you can apply another here to have a skewed cut. Here, I'll just give an example of applying a hole as well. So here, once we've applied a hole, I can change the type of hole as well. If I want a slotted hole, counterbore, countersunk, blind hole. We have many different options here. Here we can change the hole diameter as well. And if I want to modify the amount of holes in both X and Y, I can do so here. Once I've finished my modifications, here I could just validate. And once again, we'll see here, if I go back to the steel elements, we'll see the additional operations allocated here. And the price per operation as well, and this is based off the theoretical time per operation. So the theoretical time per operation, I should also mention that this takes into account machine setup time, so just actually placing the beam onto the machine if it's a beam line, and then running its operations, okay? So that's an important point to mention. And again, this would only be for small projects, or if you had a quick revision to manage on a project, for example, hole spacings on a plate, that could be done with the CAD editor as well. But whenever there's an actual revision on a project, it's always best to go into the actual models, the CAD model, make your necessary modifications, because one modification can impact many different objects in the project, right? Numbering and things of this type as well, which can cause issues with coordination down the line. So now, I'll just give an example of importing a model from Advanced Steel. So this is the UI here. It's going to enable you to select your file. I'll try to move this out of the way here. That doesn't matter. Okay, so here you have a couple of different options. You can select an SMLX file, which is Autodesk file format for BIM transfer of steel models between softwares like Revit, Advanced Steel, Plant 3D. Here we also have the option to import raw NC data, okay? We also have the ability to still keep assemblies grouped together. For example, this is a workflow specifically for Tekla structures. If you have the NC1 files and you export a specific bill of material, we can then keep the association between main part and attached part components, even though we're just importing the individual NC files. Because we have this additional bill of material, we can keep the association and how they're being grouped together by means of welding or bolting, etc. We also have Graitec's native BIM file format, GTCX. This is a format that's used between all Graitec products, such as Advanced Design, PowerPack, for Revit, Advanced Steel, etc. And then we can import ISPs as well. Here we also have an option to explode the objects. What this means is it's not the same as a CAD explode feature. This is an option to disassociate the assembly. So, for example, if you're a service center and not managing, or you're not contracted to manage the weldment or assembly of items, just processing the material and expediting, you can just remove all associations between the attached part elements so that those aren't taken into consideration for theoretical costs, actual costs, and of course the operations in your shop. Okay, with that said, let's go ahead and import the Advanced Steel model. So once again, I'm going to be utilizing this model here that I highlighted earlier. Okay. So there's a lot of data that's being displayed here. First thing to note is that all columns that you see in a more gray tone is information coming from Advanced Steel. Okay, so here we see quantity from file. Of course, that's coming from Advanced Steel. And then here when you see source name, this is data coming from Advanced Steel as well. So this HSS 14 by 14 by half inch, and then this plate naming convention, again, those are driving from Advanced Steel. And then here, of course, the association of main part and attached part components is, again, being driven from Advanced Steel. Now, you may notice that these are folders. So here I can collapse the main part to see the subcomponents, and then in addition, I can collapse the part folders to see the operations that need to be executed to transform the material. So here, just upon import, I have a default configuration to optimize my workshop. Okay, so I can write rules to suggest that every time a bar element needs to be cut, first it should be going to, let's say, the beamline machine, the Python machine, callback, whatever the case is, prior to maybe going to the manual saw. The manual saw I only want to utilize when I've hit critical mass. So you can write rules in the system to optimize the part routing at the import stage. Also, at this level, you could choose to subcontract different assemblies or choose not to produce them altogether. So if, for example, you're a fabricator and you've been allocated a specific part of the fabrication process, right, but you're receiving a model from a detailing firm and they consolidated everything to optimize holes. So, for example, they could have a special part from Advanced Steel coming in as well, which are typically mechanical components, 3D solid shapes, just to use as reference to apply holes on beams and so on. You could choose to ignore those items and not import them into your order, ignore them altogether. Here you'll see items. So these are the SKUs that are linking to Advanced Workshop from Advanced Steel. Now I've already imported this model, so it already knows that I need to associate this type of profile with this type of SKU. But if ever you need to associate an item, or you never imported an item of that type, a good example would be this gauge material here. I never had to import this before. So if I wanted to, let me just go here, select this cell. So if I just wanted to search for an item that's equivalent in my system, I can go here, press F4 to then have my SKUs available to me, and I can select the correct SKU to associate to the shape. The reason why we leave it up to the user to automatically or to manage the mapping is because you can have, for example, for a plate thickness of 1 inch, there can be many different sheet sizes that you purchase typically from a vendor. There can be 4x8, 5x10s that are 1 inch thick. And sometimes to save on cost, you might even ask your vendor for offcuts, right? To just if they have any offsets available to reduce the price. So this is why the association of mapping is done after the user has saved the mapping process, which is typical for these types of solutions in the first place, but just to mention. So here, if I wanted to search for an item that is equivalent, I can just search for the set item code and then map the item code. Okay. Now here, there's a few different ways of viewing the information. Once again, you can. There's two different modes, I should say. There's fabrication and then there's mapping. So if I wanted to just go through the process of mapping the plates or profiles that I've never had to purchase before, I can go here and just view mapping and then save the mappings, which is essentially telling the system upon next import, whenever you see the profile size, to always associate to this existing SKU. We also have a summary table where you can see at a high level the total weight of the project, all main parts, profiles, operations, plates, and special parts within the file. Here, if you wanted to just import the entirety of the model, you could select the entirety of the model, or if you wanted to just import a certain amount of assemblies or phase, you could select the items that you want here, like so. Another key feature is that we have a viewer, of course. So if you're a fabrication shop that doesn't have detailers in-house, well, receiving NC files or a bin file is nice, but you want to be able to quality control it being imported into the order. So you can have, let's say, the drawings on your desk, but then activate the viewer so that you can quality control the object and process of elimination here, like so. On that one. Side elevation, but there we go. Okay, from here now, what I'm going to do is just import these 5 different assemblies. It gave me an error for these items that weren't associated to SKUs, but that's fine. We're not importing them anyway. Okay, now from here, we have the cost breakdown for each assembly. And then, of course, we have the quantity count. And here we have the assembly name, which is retained from Advanced Deal as well, of course. And here, if we want to process the root requirement analysis, because we noticed we imported 4 different assemblies, but just calling out the assemblies here, if we want to see the data behind these modified needs SKUs that the software has created to manage these assemblies, here, if we click on process root requirements analysis, we'll see the data that has been applied, in short. So here under tree view, we can see the assembly, naming convention, and then here we can see the SKU that's utilized in all operations that needs to be executed on each part of the assembly. Here under debit, you can see a SKU reservation list. So this reservation list is showing the SKU that needs to be used for, let's say, the bar elements, or that was mapped originally. And then here we can see time coefficients, or the exact time, I should say, relative, or not the exact time, excuse me, the theoretical time applied to each operation, and then the cost. And then if you want to see more information regarding the operations themselves, so which workstation they would be managed at, the total time, the theoretical time required for machine setup, cost per operation, etc., this would be viewed here. You can even see if you have multiple workstations and multiple fabrication shops for your business, you can actually see the workshop that's going to manage the task, the bay, and then specific workstation as well. Here under accessories, if there were bolts with these assemblies, you would see the accessories, so the bolts that would need to be fastened in your shop prior. Here you can see surface area consumption for the plate, and here length consumption for the profile as well. Now here when you see scrap of X amount in length, of course this is something that can be managed. So you could write rules in the system for certain types of elements that it could exceed 2 feet in length on the drop off. You would want to keep that in stock as opposed to chucking it to the bin. Okay, so this is how you get a high-level overview of how it's broken down, the cost per operation, theoretical time per operation, and which items would need to be utilized to execute the assembly itself. From here, we can then go to manufacturing production planning. So this is going to be your main scheduling board for all fabrication orders. And here, the way this is configured is that you have an assembly. So orders, items for production planning, you have each item as or each assembly as its own unique item to drag and drop into a fabrication order, excuse me. So what this means is you can consolidate multiple assemblies from different projects in the same fabrication order, of course. Now here, just for simplicity, I'm going to select all items pertaining to the customer order of 149. So just going back to customer orders, this is the order that we just created, 149, and the 4 different assemblies that we imported. So from here, if I wanted to, let's say, fabricate all these assemblies tomorrow, I can just drag it and drop it in my schedule board, and then you'll see here that it's generated a new fabrication order number, 135, because ultimately you can have more than just assemblies pertaining to this customer order into one single fabrication order. Okay, so that's why there's 2 different numbers that get associated. But then within the fabrication order itself, you'll still see the assemblies and, of course, the customer orders associated to, and a breakdown of the materials required. So at this stage here, I want to do 2 things. First, I want to be able to validate that I can actually execute this fabrication order tomorrow. And also, I want to see if I have material in stock to execute the project. From here, we can open up our overall production planning table. So in this table, you're basically going to see your shop capacity, and if you've hit critical mass at certain workstations. Okay, so here I could see that the Kaltenbach has hit critical mass. Okay, and there's different ways to manage the routing of parts to said workstations as well. Just to go under parameters here, I just want to talk about this option, smoothing. So what this means is we can have no smoothing, order smoothing, or group smoothing. Group smoothing, or the difference is if you're launched a fabrication order for this workstation, it will not allow you to execute another fabrication order until said fabrication order is complete. But if you want the machine to allow for different fabrication orders to be executed in parallel on the same workstation, you could change it to group smoothing or no smoothing at all. Also, what it'll do is distribute the workload differently over the course of X amount of time that has been specified per operation. So the theoretical values per operation. What I mean is if you have a rush order, and let's say you have to execute all operations for tomorrow, or else you would have penalties on your project. I could suggest that I don't want any smoothing and I want the machine to operate overnight until all tasks are complete. Now you'll notice that the workload has not been distributed over the course of X amount of days. It's all consolidated into one day. And then from there, I can apply, let's say, a time coefficient to suggest that I will not just be running on my normal shift of 9 to 5. Maybe I wanted to operate until, I don't know, 10 or 12, midnight, whatever the case is, or overnight. So here, as opposed to 1, I can apply 2 as a time coefficient. And here you can see the capacity is reduced. So this is just a way to be able to distinguish based off the theoretical times how much time is actually going to be needed on this set of workstation. And of course, the theoretical times can be more conservative, so that if you do have a scenario of this type where you need to execute everything in one day, you're looking at the worst case scenario, not a less conservative time frame, if that makes sense. I digress. Okay, so from here, I'll change my parameters back. So now I've seen that I can indeed execute everything on Thursday, but just for the callback, it's going to take a little bit more time to process everything. And those operations will be complete on Tuesday of next week. This could be due to not only this one order. Keep in mind that there's other orders I executed last week, so it could be still processing orders from another project. As you see here, 148 is from another project, and those times are still pending on that machine. One other important note here is that we can actually factor in maintenance of machine as well. So you can have your own maintenance machine maintenance schedule board and allocate an individual to service the machines bi-weekly or whatever the requirements are for that machine, but you can factor that downtime in this table as well. Okay, so now that I know I can actually execute this fabrication order on Thursday, another part that I would want to manage is the automatic assignment. So from here, I can make decisions on which workstations would manage which tasks. So just a nice example here, I have 2 welding stations in my shop, and here I have welding station 2 and 1. And here you can see the production time required. So this is just to show that you can put different theoretical times even for manual labor as well. This is a huge difference. This is just to give a visual impact, all right? But welding station 1 will execute this task more quickly. And here, if we can expand the folder and see which operations specifically are going to be managed at this workstation. So we see tack welding and welding. So here's just to tack weld, it's going to take approximately 2 minutes, and then to actually weld the object, it's going to take 4 minutes. Whereas this other workstation here, there was a much larger time allocated for welding. But again, this is just for visual impact. With manual workstations, it should be more conservative and across the board. Let's just be clear. But here under profile, or this profile, I see that I only have one machine, which is the column back, that can actually execute the cut to length, holes that need to be applied, etc. Now, if ever I've hit critical mass and I need to execute by set date, you can obviously choose to subcontract at this level as well. So here I can choose to disable the operation or subcontract it altogether. And you can be specific on which operation it is as well. And another point to note here, if you wanted to just subcontract the entirety of the assembly, that is something that you can do here under properties. Something else to note here, you will have a viewer at the top right-hand corner so you can see the objects as well. And when making said changes, you can see, of course, dynamically here at the bottom in the workstations table, you can see the times alter as well. Okay, so before we end things today, another feature for material traceability and stock management, one nice feature that we have is our nesting module. So from here, you're to be able to see your stock in hand, customer reserve stock, available stock, expected stock from a vendor, theoretical stock as well. So there's many different ways of viewing your stock because of stock allocation to projects. And of course, you can have expected stock, so ongoing purchase orders that are pending. And there's just different ways of viewing your stock for these reasons. Okay. Now, if you ever have negative quantities, of course, this can be avoided in the system, and you can get you can prompt for not error message, but prompts to suggest that you need to purchase more material when your stock levels get to X value. Okay, so for example, if this is a common bar element that you use frequently, and you only have 5 left in stock, we can have automated messages appear to suggest that you need to procure this material regardless of the customer order. Okay, but here I can base this off of an infinite quantity here, and then if I use the automatic nesting feature, it'll calculate how many bar elements I need to procure with material waste in mind. Okay, so it's going to optimize based off of the SKUs I have available in my system. So what this means is when procuring this bar, only utilize either lengths of 20 feet or 30 feet or 25 feet, etc. It'll pull from what's in the system and then suggest to you that it'll be most optimal in this case if you procure. Sorry, let me expand this a little bit more here. So here it's going to suggest that ultimately I need 1 piece. Okay, for these, or the quantity of 2 to execute these 4 different bars of this specific length. And here it'll highlight the remnants, so it's only 2.5 inches that remain. And also here, there's other factors that you can alter and change with the machine configuration. So of course, when we tailor the workstations and machines, we factor in the initial cut variables with the machine parameters. And also the blade width thickness, if it's dealing with a saw, or how much material would be removed when cutting a bar element into 2. So those are factors that you can manage within the machine's configuration. And if you want, you can be more conservative with your blade thickness. Okay, you can put an actual value and an economic value. So once your nesting is saved, then you would go through the actions of purchasing. I don't think we have enough time to go through all those steps today, but this is to give you a brief introduction of how Graitec Advanced Workshop can help you manage traceability and optimization of material for a steel fabrication business, and of course leverage data from Autodesk and Steel.